Hi viewers, in this video we are going to discuss about the pumps and that is introduction, classification, specification of it, and we are going to see about the reciprocating pump in this case. Okay, fine. So this is in this elements of mechanical engineering, the module 2. We are going to discuss the turbines, after turbines, the pumps out there. So here first, what is a pump? Pump is a device which is used to convert the mechanical energy into the hydraulic energy. Earlier video we have seen what is a turbine, where in the turbine we are going to get a mechanical energy through the hydraulic energy. Okay, so that is the reverse of this. Here we are going to convert the energy of mechanical energy into a hydraulic energy. Okay, that is called the pump. So pump is used for flow of water or flow of pressure. It is used to to overcome the pressure induced in the low. Okay. Pumping of water from the sump. Normally, we want to pump the water to the overhead tank. Okay, or if you want to use any waters in your machines, that's a coolant pipe or any kind of flow of water which is required. A pump is required for the flow of water or pumping from one place to another place. So this is all required. And the lubricant oil. So in we can see in all type of components, we want to lubricate it, we need a special pump and injection pump. So the pumps are there for conversion of movement. Okay, from conversion of the energy of mechanical energy into hydraulic energy is normally we will say. There are 2 or 3 different types of pumps we are going to see here. One is a centrifugal pump and a reciprocating pump and rotary pump. So centrifugal pump, let me see what is the difference between centrifugal pump and reciprocating pump in the next videos. And before going to that specification, if you want to get a pump, so pump in the sense we have to purchase a pump. So what is the main specification is required for this is maximum discharge pressure, how much it can discharge a pump, how much pressure it can withstand. So each and every pump has a design for a particular pressure. So that is a very important thing, the specification we have to go for it. And how much amount of liquid or amount of water, it can be oil or water fluid, it can be deliver. That's what maximum discharge flow, how much per time, per period of time, how much it can be discharged, and the size of that pump, and features like whether it is what type of pump, it is a centrifugal pump or it is a reciprocating piston pump or gear pump, like that. The types, pump type, these are the specifications, and whether it is a AC source or DC source pump or hydraulic pump, so whatever it is, these are there. And now we are coming for the one of the classification, just like the reciprocating pump. What do you mean by, what do you, how the function is, function of the pump, what is the principle, working principle, we are going to see in this reciprocating. A reciprocating pump is a hydraulic machine which converts the mechanical energy into a hydraulic energy. Normally all the pumps is the principle is the same, conversion of the mechanical to hydraulic energy. In this reciprocating pump, the liquid, it is the piston, it sucks the liquid from a container of water, or container or a tank. From that, it sucks that due to the vacuum, getting vacuum creation, and it sucks, then it delivers it through a force. This is what it is, the reciprocating pump is doing with the help of a reciprocating piston. Okay, so the pump contains a cylinder. Normally the pump contains a cylinder, just like our syringe, how we are sucks the injection through the nozzle of the needle, and then we deliver it by pressing the piston. Okay, so the piston moves inside the cylinder, that is the we call it as positive displacement pump, where it consists of a piston and a plunger. The piston is present inside the cylinder. Then when when it is used in a place where a small amount of water is to be discharged. So the piston movement and how it is going to be delivered, we will see in this sketch. So the reciprocating pump, how it is going to be function. So normally at the bottom there is a imagine that there is a submerged receiver tank. It is a tank which contains the water, and there the suction pipe, the suction pipe is there, which is going to suck the water. And here you can see a cylinder, and the cylinder in which a piston is there, and the piston is connected with a connecting rod and a crankshaft. So just like in IC engines, how the piston movement is connected with the crankshaft and the things, here we are connecting with the motor. When the motor is going to be rotated, electrical motor, when we start rotating the motor rotates, and the crank which is connected with the motor, it pushes and pulls and push the piston. To and fro motion of the piston can be caused with the help of the rotation, and this cylinder, inside the cylinder a vacuum is getting created. When the motor rotates half of this, it will create the suction, and the water is getting sucked inside. So you can see here the important parts of this is cylinder with a piston and the piston rods, connecting rod and a crank. As in the case of IC engines, we have seen here also the same thing, but it is connected with a suction pipe and a delivery pipe. So the function of the suction pipe is to sucks the water. So there is a suction valve and a delivery valve. So the suction valve will get opens, and the water gets in through the suction valve. So when it happens, let me see one by one here what will happen when the piston moves towards and away from this. Here we are having a cylinder with a piston, and the piston rod is getting connected with the connecting rod and the crank. So cylinder, when it moves towards the right side or backwards, when the crank is rotated, when the crankshaft is rotated, the crankshaft which is connected, it moves, pulls the piston backwards. So when the piston moves backward towards the crank side, then here it creates a vacuum inside, and the suction valves opens up. When the suction valves opens up, the water enters into the cylinder, and when the piston moves to the dead end, the total suction has taken place. And when the crank is rotated in the second half, the piston moves forward, and when the piston moves forward, the suction valves getting closed, and the delivery valves, it gets open. So the suction pipe is connected to the inlet of the pump where the water tank is there. So when the piston moves this side, the sucks the water, and now the piston moves towards the cylinder head from the crankshaft, so that the delivery pipe which is connected for the delivering of water, so that it is the output line. So delivery pipe, and the delivery pipe and the cylinder is connected with having a valve which is called the delivery valve. The delivery valve opens, and it sends the liquid out due to the compression of the piston, and remains closed when the water is sucked in. So the delivery side and the delivery valve and suction valves are most important in this for the suction and delivery of water. So the air vessels are used for the discharge of water, and this is how a single acting reciprocating pump is going to open. So during the suction stroke, the piston moves backward, and the suction valve opens, the water enter into the cylinder, and after the completion of the suction stroke, the suction valve closed, then piston moves towards the head. Okay, then delivery valves get open to the delivery valve, and the delivery pipe, the water gets out. So this is how the reciprocating pump, the front and backward movement of the piston sucks the water and delivers the water. So the advantages is the priming process, which is needed in the centrifugal type, which is not present here. It is not required. We will see what is that in the next video when we are coming for the centrifugal pump. And it produces high suction lift. So it is used for air, hydraulic and pneumatic, both the type of pumps it will be used. And because of more water wear and tear, its disadvantages, maintenance will be more because of piston movements and it rubs along the cylinder frequently. The wear and tear takes place, so and the flow rate will be lower. This is heavy and bulky in size. So this is what the application is: low discharge rate, and it's delivered at water at high level. Okay, and it is used for the bicycle tire inflation. So compressor works, all the things, it works under the principle of the reciprocation motion. So this is what the information about the reciprocating pump. In the next class we will see about the centrifugal pump.